So we're going to go walking through a couple recursive examples. So we did some examples of writing recursive methods, and now we'll trace through some examples of tracing recursive methods. So this first method here, we're going to trace through. We can see that it's a valued method, so it returns an int, takes two parameters, x and y. We have a base case here, and we have a recursive case here. Okay, so let's go through and trace this method. Now remember that when we trace recursive method calls, just like when we trace any method calls, when you invoke a method, you create a new activation record for that method. That activation record gets put on the top of the stack, and then you execute. When that method is done, the activation record gets popped off the stack, and whatever activation record is below it is now the current one that you continue executing. Okay, so these are my little activation records, and I've simplified. I took out the local variable since our example here isn't using any local variables. I just keep the screen a little shorter on the activation records. I took that part out. So our first thing is we're going to invoke this method with parameters 5 and 1. So we're going to invoke the rec method 1, and our parameters are x is being sent the value of 5, and y is being sent the value of 1. So this is the activation record that gets put onto the stack. And as I go in here and execute, is x equal to y? No, it's not. So I go into the else. And the else is saying, okay, I have a return statement. So what I'm going to return is, oh, wait a minute. I have to wait because I have a call to another method. So I can't finish executing this statement until this method executes. So this whole method gets put on pause. And we invoke the next method. The next method just happens to be the same method, but because it's a new invocation, we get a whole new activation record. So now we, again, have an activation record for our rec method 1. X is sent the value of x minus 1, and this x is the current x, so 5. So x is sent the value of 4, and y is sent a value of whatever y is here, which is 1. Okay, so now this activation record gets put on the stack, and we start activating this current method. So we come in here, is x equal to y? Nope. So we go into the else, and the else says, okay, now I have a return. What I'm going to return is, oh, wait a minute. I have to pause this method because I'm invoking another method. So I have to wait and invoke this method. So I set up a new activation record for this new method. Just happens to be the same method. And here I'm going to go in and I'm going to say, okay, my parameter x is going to be whatever my current x is minus 1, so it's going to be a 3. And y is going to be whatever my current y is, which is 1. And so this method now gets put on the stack. And now we start executing this method. So we come in here and we say, is x equal to y? It's not. So we go into the else. The else wants us to return, oh, another method. So we have to pause, create a new activation record. Again, this would be the same thing that would be happening if we were invoking some other method, like method 4. Just so happens that it's the same method. And this now gets put on the stack. And we start executing, but is x equal to y? Nope. We go into the else, but wait. We have another method call, so we have to put this method on pause. And come in and have another method call. And now this is actually going to be on the top of the stack, but just because I can't see it, I'm going to leave it here for a moment. So when we get into executing this method, we hit the if statement, is x equal to y? Oh, it is. So we execute the if. The if is just a return of 0. So now this method is done. It gets popped off the stack, and its return value gets sent back to whatever method invoked it, which is here. So this method is now done. Activation record is gone. Those formal parameters, and if we had had any local variables, they get garbage collected, so they're gone from memory. And now we continue with the execution of this method, which we left off right here. So that's where we pick back up, which means we finish the statement, which is 0 plus 1. Okay, so now this method is now done, which means it gets popped off the stack, and its value 1 gets returned to wherever that method was invoked from, and this activation record is gone. So it was invoked from here, so we now have a 1, and we can now pick back up in where we left off from this method, which is again in this location here, and we return 1 plus 1. This method is now done, so it gets popped off the runtime stack, and the value 2 gets returned to where that method was invoked. And this method now picks back up where we left off, which is here, and this is in the middle of a return statement, so we're going to return 2 plus 1. This method's now done, so it gets popped off, and this value of 3 gets returned here. And now we pick back up with this method, and we had left off here. We have a return value of 3, so then we pick back up with that statement, which is a 4. This method is done, so it gets popped off. And now in my console output, my original invocation, which was printing out, I print out the return value, which is 4. So what this method's actually doing is, can anyone think of what it's doing? It's actually subtracting 5 minus 1. So this is a recursive solution to integer subtraction. And again, the key here when we're tracing through outputs is to create a new activation record for each invocation of each method. Doesn't matter if the method is the same method you're in or some other method. Every time you invoke a method in Java, you create a new activation record, and you put that activation record on the top of the runtime stack, and that activation record is then the one that you execute. And you execute that method all the way to the end. If you have another method that gets invoked inside that activation record, you pause, you create a new activation record, push it on the stack, and then that's the one you activate. And then finally, when you get all the way through a method, you pop that method off the runtime stack, you pick back up, you kind of press the play button on whatever method was holding underneath it, and that's where you resume. And then you resume that method to the end. When that method's done, you pop it off the stack, pick back up with the one underneath it. Okay, so that's the general approach for really tracing any Java program, whether it uses recursion or not. It's just often a lot easier to trace programs that don't use recursion, and we need to think a little bit more about it when we're using recursion. So let's trace through a couple more methods. Here is one where we have 2 factorial methods. This is recursive factorial 1, and here you can see we are printing out x, and then we have a base case. If x is greater, sorry, this is my recursive case. Just because it comes first doesn't necessarily mean it's the base case. So we're saying if x is greater than 1, well, I don't know how to find the factorial of x, but I knew if I could find the factorial of x minus 1, I could multiply it by x, and then that whole returned solution would be the solution to my whole problem. So that's my recursive case. My base case is if x equals 1, assuming that this is being invoked with a positive or non-negative number. My base case rather is just 1, right? So the factorial of 1 is just 1. This is another way. So this is the method using return statements, and then this is the same implementation using a local variable. So my local variable, we declare a local variable factorial, and I haven't initialized its any value. In this case, I'm actually going to initialize it in my base case and my recursive case. So let's look at the recursive case 1. First of all, if x is equal to 1, my local variable fac is just 1, because the factorial, again, of 1 is 1. For my recursive case, if x is greater than 1, I say, okay, that local variable is going to be given the value of x times whatever solution I get to my reduced problem size. And then after I'm all done with both my base case and my recursive case, I return my local variable. Now the only other thing that's in here is a print line, and we'll take a look at the results of that print line when we do our trace. So let's trace this with factorial of 4. So I'm going to be invoking first rec factorial 1 with the initial value of 4. Okay, so I'm first creating an activation record for rec fac 1 and x equals 4. So what's going to happen is that this is my current method that's being invoked. Put that method on the stack. So now I start executing that method. The first thing I come to a print line. So I'm going to print 4. Okay, and then I say, is x greater than 1? Yep, it sure is. So I go into my if statement, and I hit a return. I'm going to say, okay, return 4 times, pause, wait, and I'm invoking another method. So I am invoking in a method, which means I create an activation record. That activation record is for rec fac 1, and my parameter that I'm sending in is x minus 1. X from the current activation record is 4, so that means my parameter that I'm sending in, the actual value, is 4 minus 1, or 3. So I now put this method on the stack, and now I start executing. So I go in here, I print out x. X is 3, right? Then I go in here. My if statement is x greater than 1. It sure is, so I get a return, and I'm returning x times, oh, wait, I have another method invocation, so I want to get a new activation record for that method. What method am I invoking? I'm invoking recfac1. What value am I sending for x? I'm sending x minus 1, so 2. So I put that method on the stack, right? Now I start executing this method. So I go in here, I print out x, and then I keep executing. Is x greater than 1? Yep, it sure is. So I'm going to return 2 times, oh, I have to wait because I'm invoking another method. So now I create an activation record. The activation record is for the method again, recfac1, sent with the actual parameter of x minus 1. So that's 1. Put that method on the stack. Go ahead, get in here, execute. So my first one is a print line. And then I keep going. Is x greater than 1? Nope, it's not. So now my if statement fails. So I go into my else and I return just a 1. So now this method is done. I pop it off the stack and I return that value to where that method was invoked, which was here. I can now resume this method invocation with where I left off, which was here, which is just the end of my return statement. So I'm just going to, now this method's done, pop it off the stack. Return statement of, or return value rather, of 3 goes here. And this method can now resume with where it left off, which was, again, this same line, just the end of the return statement. So this method's done, pop it off the stack. The return value of 9 goes here. And 4 times 9 is now 36. This method can pick back up where it left off, which is just a return statement. So this method is now done. Pop it off the stack. And we are now, did I have a mistake there? No, sorry. I think I had a mistake in my trace there. Anyhow, this value here would be returned. Yeah, this should be a 24. I think I did 3 times 3 instead of 3 times 2. Sorry, I have a little mistake there. Hopefully you caught it when I was tracing through. But now this value of 24, this method's done. It's popped off the stack, garbage collected. So our return value of rec factorial 1 sending in a 4 is going to be 26. I'm sorry, 24. And our output would have been 4, 3, 2, and 1. Okay? So let's now trace through the other way of running with a local variable rather than multiple return statements. So let me put back in my local variable into my little activation record, and let's reset the console output. Okay, so now I'm going to again invoke my factorial method, but I'm going to use the second one, and I'm going to again invoke it with 4. So my x is going to be equal to 4. So this method now gets put on the stack. And now I come in here and I declare a local variable, fac, and I hit my if statement. Is x greater than 1? Well, yes it is. So I move into the if statement. My if statement says, okay, initialize fac with the value of x times, oh, wait, I have a method invocation, so I have to wait. So I have a method invocation, which means I create a new activation record. That activation record is for rec factorial 2 with the formal parameter x being x minus 1. X is 4, so that means in my current activation records, that means my new activation record variable, or parameter rather, value is going to be 3. Put that method on the stack. Now I start executing this method. When I get in here, the first line is creating a local variable, fac. I hit my if statement. Is x greater than 1? Yes, it is. So fac gets the value of x, which is 3, times, oh, I have a method invocation. I need to pause. Put this method on pause, create a new activation record. That activation record is again for recfact2. That's the name of the method. The formal parameter of that method is x. The value of x is going to be current x minus 1, so it's going to be 2. Put that method on top of the stack. Now we start executing this method. So the first line is the declaration of a local variable, fac, and the if statement is x greater than 1. Yes, it is. So we go into the if. The if now says, okay, that variable fac should be initialized with the value of 2 times, a method invocation. Put it on pause. Create a new activation record. So that activation record is again going to be for recfactorial2. And the formal parameter of x gets the actual value of 2 minus 1, or 1. Put that method on the top of the stack and start executing. When I go in here and execute, I declare a local variable, fac. Is x greater than 1? No. So now my if statement fails. I jump into my else. Inside my else statement, the local variable fac is initialized to 1. And now my if else is complete, and I continue on with my method, which is just a return statement. So I'm going to return fac, which is 1. This method's now done, so I pop it off the stack, and the formal parameters and the local variables get garbage collected. They're gone. The value of 1 gets returned to where that method was invoked from, which is here. This method now picks back up with where I left off. Okay, so I pick back up here, and I've now initialized fac to be 2. I go in and I continue on with this method. The next statement in this method is a print line, so I'm going to print out x, which is 2. And I am now out of my if else. I continue on with my return statement. I return the value of fac, which is 2. This method's now done, which means it gets popped off the stack, garbage collected, and that value of 2 gets returned to wherever I was waiting on pause, which is here. So now I pick back up with this method. I paused right here, so I pick back up. I now finish assigning or initializing the value of fac with 6. I print out my x, which is 3. And then I jump out of my if else. I get down to the next line in my method, which is just a return statement. So I'm now going to return the value of fac, which is 6. This method's now done, so I pop it off the stack. The formal parameters and local variables get garbage collected. The return value gets sent to the next method that's been waiting for it. So it gets sent here. And this method can now resumes here in this line. And I finish initializing the value of factorial. I then print out x. And I'm now done with my if else, so I jump to my return statement. My return statement is just going to be return fac, which is 24. This method's now done, so this activation records get popped off the runtime stack, and the formal parameters and local variables get garbage collected, and the value of 24 would again be returned for factorial. So these two methods differed, first of all, because this one used multiple return statements. This one used a local variable that is updated with, again, in both the base case and the recursive case, base case and recursive case, and then just a single return statement. But they both calculate the same thing. So these both calculate a factorial. This one just does it with a return of the recursive statement and a return in the base case. This one does it with an update of a local variable in the recursive case and the base case, and just a single return at the end of the method. So they differ in how they implement, but they accomplish the same task. The other thing that these two methods do differently is our first invocation of our factorial method had the print statement before the recursive call. So you can see in the method here we print and then we have our recursive call. The second factorial method had the recursive call and then the print. So that's why when we had our first method that we trace, our printout was 4, 3, 2, 1. And when we had our second, our printout was 2, 3, 4. And that matters because in the first one, the print happened before the recursion, and in the second one, the print happened after the recursion. So you do have to keep track of where the recursion occurs in your method, because if there are other things going on, like print line statements or other updates, other calculations, it matters whether those things happen before or after the recursive call. So that's something to pay attention to. Okay, so we're going to pick up with one more trace of a recursive method using an array in the next video.